Hi, welcome back to the breadboard. In the video where we upgraded my Tronxy X5s to 24 volts, I talked about the fact that because of the resistance of the heat bed and the fact that the power supply is only rated at 15 amps, I had to turn down the voltage of the power supply to about 19 volts so that I wasn't trying to overdraw with the 15 amps, which is, even at that, it was still drawing 15 amps. Now, I also mentioned in that video that the wiring should be upgraded, especially if you're going to go above the 19 volts, if you want to go to a full 24 volt power supply. Now, I titled this video Wiring Matters. Why? Well, because it does. And what I want to show you here is why it matters. And I'm going to do that with a practical demonstration, including a thermal camera on the wiring and the heat bed. And I'm going to show you it working with the original 12 volt power supply. And we're going to run it up as hot as it can go. Then we'll do it with a 24 volt power supply, but tuned down to 19 volts, which is the one that's currently installed here. And then I'm going to put in a power supply that my friends at RS Components sent me, which is a 24 volt 20 amp power supply. Now this is a big beast. It has no active cooling, which is why it's so big. It's got big, huge heat sinks in it and everything else. Designed for DIN rail mounting. Now I might actually ultimately put it in here, but if I can get one that's perhaps a little smaller, then that might work better. But for now, this one from RS Components is actually a Meanwell power supply. Will do the job so that I can run this heat bed at the full voltage and current. And at that point, you're going to see something very interesting with the current wiring. Now, just to clarify, this is the wiring that came with the Tronxy X5s. It's 16 gauge wire. I'm not sure how good a quality it is, but it's 16 gauge. And the heat bed is about 1.25, 1.27 ohms. To start with, let's just get this rewired to the 12 volts, and we'll do our first capture. And what I'm going to be trying to capture is the temperature of the heat bed, so we'll actually see how hot it will get, but also the temperature of the wiring. And I've got a multimeter here, and we'll also look at the voltage drop in the wiring. And this is where wiring matters, because you're going to start seeing some significant voltage drops in this wiring. And ultimately we will upgrade it, and you'll see how much of an improvement that will make. Anyway, let me just get the 12 volt power supply. I'm just going to have these loosely wired up on the bench for the sake of this. Obviously, when I'm done, it will all be wired up and protected and everything else. So I just want you to see why I keep saying wiring matters. Okay, I got the 12 volt power supply re-hooked up. It's out of shot because I don't want my thermal imager to be looking at it. I'm going to start the thermal imager as well, which is going to be looking at the heat bed and this piece of wiring right here, because I want to measure the temperature. So what I'm going to do in all cases is I'm going to tell it to heat up to ABS temperatures. That way it won't cut off. It's just going to go as hard as it can and try and get up to about 110 degrees. So let me just start the thermal imager capturing. I'm using a FLIR AX8. I'll put a picture up so you can see it, and I'm capturing the stream video coming from the FLIR AX8 using Snagit. I've got some software that can also do it, but it's easier for the sake of my editing to just do it this way. So we can see this heating up. Once we start the printer, I'm going to tell it on the front panel of the printer to just go to ABS preheat, and we'll see what happens with the heat bed and the wiring when we use 12 volts. Okay, all the shiny things have been moved out of the way. I'm now going to tell the printer to heat up ABS, preheat to ABS. And I'm just going to do the bed. Right, that's just that started. So it's going to try and take it up to 110 degrees centigrade. I will speed up the video for this once it's going. Now, just to show you, I've got a multimeter set up here, and I'm going to measure the volts on the heat bed. as well, just to show you what is actually reaching the heat bed. Alright, so there we have I can't see the meter. Hold on. So we have 11.47 volts on the heat bed. The output of the power supply is 12.3. The volts being sent at the point down here of the wiring after the MOSFET is 11.9. So we're dropping 23 millivolts on this MOSFET, which is not a lot at all. But more importantly, in the wiring, we're dropping, just in this length of wiring, 11.9 there and 11.48 there. So let's say 11.5. So we're dropping 400 millivolts just in this wiring. And we're only drawing about 8 amps. The thermal imager will be showing some interesting things right about now. So you can see here on the thermal imager, box 1, we're already up to, just after a couple of minutes, we're up to about 30 degrees. Now remember, we're not going to get very hot because we've asked for 110, but we're only running this on 12 volts. You can see the wiring, which is inside box 2, the hot spot there, max, on 2. The wiring is also up to 33 degrees already. I guess I'm slightly misaligned with my spot temperatures. So we're up to about 43 and a bit now on the heat bed. It's still rising slowly. As I said, it won't get much above 50. Oh, in fact, my software has just given up because it stopped rising enough, and it came up with the heat alert. And we'll just set that going again. As I said, we know it wasn't going to get to the temperatures we wanted anyway. Alright, let's turn back on again, see if we can bring it up a little further. I put a different shield in front of the wire so we can see better, hopefully, what's happening without reflections from behind it. Yeah, that's a lot better. You can see actually the blue tack thing now, the wires in front of it. Now my camera is very close to the wiring, so I'm having a bit of difficulty just getting the alignment here. But you can see there's the wires. I put a build tack over the front of it so that it doesn't get any reflections from behind here. And here's the thermal MS. I just go thermal alone. You can see this is the wires. Now you can see that clearly is just the wires. I know it's still heating at the moment because I can hear the fan going on the power supply. So you can see we're up to about 42 degrees. And I know that it's going to barely get to even 50, so I'm not going to bother trying to push it even further. Now what I am using is 16 gauge wire all the way through right now. So I think that's probably enough of that. So we know that the wiring is getting up to about, where is it? It's box number 2. 35 degrees at its max. Okay, let me stop this for now because it's not going to get, it's according to this thermistor it's up to about 52. According to my thermal imaging camera it is up to 44, so we're a little bit of discrepancy, but I'm measuring with the thermal imagers measuring on the top of the heat bed, and the thermistor of course is measuring directly against the heaters on the bottom. So probably getting a bit of time for the thermal mass to heat through. It would probably catch up, but it's certainly not really going up much further than that. You see, it's only up to 44 on the spot temperature. Okay, I've rewired for the 20 volt supply this time. Let me just bring the meter back into view. So we're using this power supply. It's a 15 amp 24 volt power supply, but because of the resistance, like I said, we can't run it at the full 24 volts, so it's dialed down. It's turned on right now. The supply voltage without a load, 20.07, yeah, to 20 volts exactly. Now I'm going to do the same thing. I'm going to tell it to heat ABS, so it's going to try and get to 110. You can see from the thermal image it's not cooled down from before, which is fine. That means things will be a little quicker. And I'm going to tell it again to do the exact same thing. Prepare preheat ABS, and just for the bed. So I'm going to go now. So we're starting off at 42 degrees according to the thermistor on the bottom, and we're going to be drawing a lot more current this time. So again, I will measure the voltage coming out of the power supply. So we've got 19.9, so close enough 20 volts, 19.96 volts there. And what is reaching the bed, 19.1. So 19.1 on the bed, 19.9 on the MOSFET, going into the MOSFET. And across the MOSFET, if I can just check, MOSFET's not even getting remotely warm. Nevertheless, that's still, you know, it's going to be 15 amps, so 94, almost 100 millivolts at 15 amps, that's about 1.5 watts. Not a lot. Easily handle it. So, let's let that warm up a bit. Let's go look at the thermal imager and see what it's doing. Alright, so now we're seeing some significant differences here. Heat bed is already up to 50-51 degrees. But look at the wiring now, it's becoming very distinctively warm. There's some other reflections coming on off down here, which is interfering down this part, or it might be some other things that are just blocking it, like this metalwork. It's just, as I said, the alignment of the thermal imaging camera and the visible camera is slightly off, so the picture is going to be different to the thermal image. If I just go thermal only, right, you can see there where it's being hidden from other things, like this metalwork. Alright, so wiring is now up to, well, it's rapidly increasing towards 50 degrees, the hot spot right here. So the nice things about these box areas is that they do find their own hot spots automatically. Like this one is tracking it, same as over here. So the bed now is up to 54. Now I've told it to go on 10. We already know it will go up to about 70 odd fairly well. But my thing of interest is this wire. As you can see here, it is now getting quite hot. And if I actually go and measure the drop just in that piece of wire, you will see, well, here, what I'm talking about. So we know that there's 15 amps going through this thing. If I measure the volts just in one of the wires, don't think it matters which one, they're both about the same. Okay, so I'm on one end here and here, so I've got, on just one wire alone, I've got 330 millivolts. Okay, so that's going to be the same on the other one, both wires are the same length. So that's 600 odd millivolts just lost in those two pieces of wire alone. That's a lot of power being lost, right? Never mind the MOSFET's not going to be dropping much, we already measured that. And these wires are decidedly warm and starting to get quite floppy. I can feel the heat in them. According to this, we're at 76 degrees on the display, so we're measuring with the thermistor, we're up to 77, so it's still creeping up on 20 volts, but it has slowed down. And according to the thermal imager, the heat bed, it's sitting on the top surface. We're sitting at about 64 right here on box 1. But you can see the wiring is distinctly getting hot. It's up to about 44, 45 degrees. Now that's nowhere near its temperature rating for the insulation. That's about 100 odd degrees, I think, according to what's written on it. But as you saw with the measurement, 300 millivolts just being dropped there is quite significant. And this is one of the reasons why when you start putting higher currents through to your heat bed, that we start getting fires and things like that if you don't wire things up appropriately. Yeah, so you can see here it's creeping up slowly. We're up to about 68, 70. I know that the thermostat is going to read more on the bottom, but also what matters really is what temperature you've got on the top. So we know that it's not really going to get much above this 70. It might creep up after if I give it long enough higher, but it's not going to get there very quickly. What's more important here is the fact that this wiring is distinctly getting hot now. We're up to about 45 degrees on this wire, and that is on the outside of the wire. So you've got ambient cooling it down and things like that. The actual wire itself is probably going to be a few degrees hotter. It's cooling down rapidly now, but we got up to quite a high temperature. Anyway, let's go and rewire now for full 24 volts, and this is where the fun will begin. So I'm just going to pause the video here and rewire everything for the big power supply. Okay, now we have a 20 amp 24 volt supply hooked up, and the output volts of the power supply, as you will see, is a full 24 volts, 24.2 actually. So what I've also done is I've used 12 gauge wire. This wire going to the MOSFET is 12 gauge, so I want to minimize the losses in the wire. It's about 1 meter long, which actually makes it a similar length probably to the wire going to the heat bed, which is 16 gauge, not 12 gauge. I did this for 2 reasons. One, because this is a piece of cable I've got set up just for testing purposes, but I also wanted to show you the difference in voltage drop between a higher gauge wire and a lower gauge wire, and also the temperature difference. So this is actually going to draw pretty close to the full 20 amps now, so it's going to go up another 5 amps or thereabouts, and we will now be able to get much higher temperatures on the MOSFET. Sorry, we will now be able to get much higher temperatures on the heat bed because we've got the full current capability to drive it in. We've gone up quite significant in the watts that we're producing on the heat bed. It's currently sitting about 56 degrees. So I'm going to do the same thing, prepare, and then preheat ABS and bed. So same difference, we've set 110 degrees. We're at 54. We're monitoring the wiring, and no noise this time because this is power supply, just has passive cooling, not active cooling. So just for the sake of completeness, the volts coming out of the power supply is still 24.2. The volts at the MOSFET with the 12 gauge wire is 24.0. So we've lost 0.2 volts. Right? And if I actually go positive to positive, we should see 100 millivolts, close to. Yeah, so at 20 amps, even with this 12 gauge wire, we're losing almost 100 millivolts of volt drop. That's 12 gauge. So this thing is slowly heating up. Currently the thermostat thinks it is 64 degrees, so it's heating up quite quickly. But let's measure the volt drop on one of these wires now, the 16 gauge ones, to the heat bed. Right, this is just 1/2, and we've got 400 millivolts, which is insane. All right, 400 millivolts at 20 amps, so 2 4s are 8. So we're dissipating 8 or 9 watts in just one wire, and we've got 2 of them. And these wires probably now are getting quite hot. The volts reaching the heat bed in this case, I can get in there and measure, is 23.1. So 900 and a bit millivolts just dropped in the piece of wire, 1 meter long. Whew. As you can see, temperatures are rising fast. The heat bed is up to about 66 degrees, which is nice. I'm measuring at an angle, so there's going to be some reflections and things like that. I might not be getting a perfect reading, plus who says the heat bed heats up perfectly evenly anyway. But what's interesting is now the wiring, so box number 2, is already up to 51 degrees centigrade and rising. Now that's not surprising, considering we're dropping 950 millivolts at 20 amps. So that's going to be close to 20 watts. I mean, that's a lot of heat being dissipated in that wiring. If you've got slightly worse wiring, and this is, I don't know the quality of this wire. This is what came with the printer. But I do know that, close to 20 watts in this wire, and then the wire that I actually used, the 12 gauge wire that came from my local hardware store. It's made in Taiwan as well, so it's not like it's local Canadian made or American made wire, but it's 12 gauge, and that was only dropping 200 millivolts, so a fifth of the voltage drop. But that 200 millivolts at 20 amps is only going to be 4 watts dissipation, as opposed to 20 watts of dissipation, so a fifth of the wattage. I think I got my math right there. Anyway, it's tough to tell how far up this will go. Let me just go check on the printer to see where it's at. So the printer at the bottom thinks it's up to 93 degrees centigrade. There's going to be probably quite a thermal gradient between the bottom and the top. Actually, I have a little probe here. This got sent to me. I did a video on this probe a few days ago. This is a little thermal probe from RS Components. So what I'm going to do is I'm going to point it on the top of the heat bed and see what it tells me. So this is reading 95, about 95, which actually correlates exactly to what the thermistor is reading on the bottom, which is saying 96, 96. If I point it on the bottom, ooh, that's reading 100 and, according to this, it's on the bottom, it's reading 108, 109 degrees on the bottom. So there's definitely a thermal gradient of almost 10 degrees between the bottom of the heat bed and the top of it. So the thermistor is probably not quite calibrated properly because it's reading low at this high temperature area. And the thermal imager, well, this is currently reading 97, 98. I can't see the thermal output right now. It's in a different room on my computer. So it's reading just getting up to 100. Let's quickly nip back in the other room and see what the thermal imager says before it changes too much. So it's reading, the hottest place on there is about 880. It seems rather on the low side. Might be with the angle. Anyway, it's not really the heat bed we're looking at here, it's what's happening with this wiring. So you can see here the wiring now is the hot spot. It's about 52, 53 degrees. And if I actually go and look at that wiring, and actually feel it, I bet you it's going to be like a wet noodle. Yeah, it is. That's distinctly hot. It's still heating. But it's getting quite floppy and very soft from the temperature. So I think that shows you that, 16 gauge wire with a probably amount, 20 amps, 24 volts, 480 watts thereabout heat bed now. So with a 12 volt system, we're only pulling about, I think I calculated about 8 amps. I'll put up the proper calculations up on the screen. We're only talking less than 100 watts, 12 volts, 8 amps, yeah, less than 100 watts, 96 watts thereabouts. With a 20 volt system, we take that up to 20 volts at 15, so probably about 300 watts. Actually, it's 19 volts, so a little bit less than that. And with a full 24 volts with 20 amps, which is what's going out of this, or close to 20 amps, we're up to about 480 watts. So we've considerably increased the amount of power going to the heat bed. But now, as you can see, it is actually finally reaching the temperatures that is advertised. But you can also see that if you're going to do this on your printer, you really got to up the gauge of the wire. And you can see here my wire coming from the power supply, the 12 gauge wire, is not getting anywhere near as hot. I'm going to move the thermal imager for a second. I think we've seen enough now to complete this video. You can see that the wiring has got quite hot now. I don't know where it's up to now, but it's quite significantly hot. I don't know if my probe will actually measure the wire. I don't know. It's a area map, so I think the highest this is showing me is about 40 degrees. If I put it closer, maybe I can get it higher. 45. Yeah, so it's 50 or more degrees. That's not the best thing to do this. Anyway, let me move the thermal camera to the 12 gauge wire. I'm not going to show you me upgrading the wire in here. This wire that's going down to here. I'm going to change it for 12 gauge. But I will move the thermal camera so that you can see where it's got to. So let me just disconnect it from the tripod. I'm just going to pan it around a few things. So here we're looking at the wiring that's going to the 3D printer. I'll have to put temperatures up once I review this because I can't see this myself. There's my power supply. As I said, it's a passive cooling power supply. I'm going to put this directly over the heat bed, see if we get a different reading, because it's supposed to be getting up to 110, and according to the LCD it is at 110. It's been sitting there for maybe a minute or two now, so I'm not sure what temperature that's at, but we'll find out when I review the video. So you can see with 12 gauge wire why you should upgrade to it when you're using a 24 volt 500 watt ish heat bed. Now my TiVo Black Widow has a 24 volt heat bed, and it can easily get up to the temperatures. I think I calculated it to be about 360, 400 watt, and it's physically insulated underneath as well, which also helps. Now this would help if I insulated it underneath. You'd lose more air, heat to the environment, which means more would be pushed up through the bed to the top. Anyway, I'm going to kill this heating now. And there's no point in heating it for no reason. Just bringing it down, cool down, there we go, turn it off. And that pretty much completes it. What I wanted to do is show you, literally, why wiring matters. And I think that little demonstration there, I know it ends up being about a half-hour video. I'll try and cut this right down. And that little demonstration there, I think clearly shows you that if you're using the wrong gauge wire for your heat bed, especially, because that's the one that draws a lot more current than anything else, it will get hot and it could cause you problems, especially if you've got frayed or bad quality wire being used. I don't know the quality of this wire, but it is already very quickly getting up to 50-60 degrees centigrade just in the wire. You're also throwing away a lot of power that you really don't need to throw away. Using 12 gauge wire for something that's running about 20 amps is definitely what you want to do. Thermally insulating the bottom of the heat bed will also help, etc., etc. Anyway, I hope you liked that video. As I said, I wanted it to be something fairly simple and easy to understand, and just literally demonstrate what happens with these wires. So that's pretty much it. Hope you liked it. If you did, give me a thumbs up. If you didn't, well then don't. But either way, I'll see you on the next video. And I think I might make running this thing with this 24-volt power supply a permanent fixture. I will try and get maybe one that's a lower profile, because if I put this on here instead of that one, I'm going to lose a few centimeters of build height. Not that I've ever built anything that's required that build height, but we'll see. Anyway, as I said, I just want to give a second call out to my friends at RS Components. They provided me this Meanwell 24-volt power supply. Nice thing about this is, as I said, it's deadly silent because there's no fans. It's all passively cooled. You can get your power supplies from somewhere else, but you buy from somewhere like RS Components, you get reliability, you get good quality service, you're getting good quality components. The little thermal probe was also provided. I got this a few weeks ago for review from RS Components. If you ever wanted one of these, I'll put the link in as well. And my FLIR AX thermal imager right here is also from RS Components. Whoops, get that in view. There we go. This is an industrial thermal imager, and as you can see, that I showed you in the thermal views, you can do quite a few different things, setting up multi-zones to monitor. It automatically tracks high and low and average temperatures, etc., etc. I do have other thermal devices. I have a FLIR multimeter, the DM284, which does a nice job, but you can't record from it. You can't even capture a picture to an SD card. It's just for industrial troubleshooting use. So you're up at a panel or something like that, and you just want to look at the temperature of some switch gear or controllers while you're measuring voltages and various other things. It's not really meant for longer term monitoring and capturing any kind of imagery for later evaluation. FLIR does have other devices for that. Anyway, all I have right now is this AX8, which has proved very useful for doing this demonstration. So, with that all said, it's a wrap. Bye.